Cool. Sounds good. Well, yeah, thank you so much for having me, everyone. It's always a pleasure to hang out with the Absolute AppSec folks. I'm a big fan, so yeah, honored to be here. Um, I promise this is the only slide that is annoyingly Christmas themed, but I just liked your artwork, and I was like, oh, I'll figure I'll just borrow it. Yeah, and feel free to check out these slides. There's a link here and on the last slide as well, so don't feel like you have to screenshot or write everything down. But yeah, so basically this talk is 3 parts. So first, I'm going to talk a little bit about why I believe secure defaults are significantly better than trying to find all the bugs, and try to give you like an intuition behind that, as well as look at case studies from a bunch of different companies who feel similarly. And then I'll talk a little bit about like a high-level methodology for how can we like target entire vulnerability classes to try to eradicate them. So sort of like strategic AppSec program stuff. And then finally, in the third section, we'll get a little bit more tactical and talk about sort of tools and techniques to do it. So overall, that's the structure of the talk. So just very briefly about me before we get into it. Hey, I'm Clint. I work at R2C. This is our obligatory Zoom screenshot of our company. We're basically trying to build tools and processes that allow teams to scale their security. So lots of ways to do it, and we'll talk about some of the things later. But really what we're going to discuss today is all sort of like company and tool agnostic, like 90% of this talk. Before this, I was a security consultant at NCC Group. And before that, I was an indentured servant / grad student at UC Davis. Feel free to say hi on Twitter. Always happy to speak with people. And I do have a security newsletter called TLDRsec. So feel free to check out that as well. Okay, so I think that there's been some significant shifts in technology and how software has been developed in the past, say, 5, 10, 15 years. And I think similarly, we're seeing a trend in security as well, though it's still early stages, right? So we saw, going from waterfall development to agile, going from separate dev and ops teams to DevOps, going from on-prem to cloud. And I think similarly, I've been observing this trend across a number of companies where previously there was this focus on finding vulnerabilities. And going forward, I see this instead focus on sort of secure defaults and invariants, like holding things that must either always or never be true. So as a motivating example, I'd like to ask you, does this application have XSS? Realistically, you'd be like, well, I have no idea. I haven't seen it, right? So you probably have a bunch of questions like, what does the user control? What is the structure of the data? Does the web application filter it or process it? How is it stored in the database in terms of, is it stored as like an integer or a float or maybe, JSON or something like that? Maybe the database itself matters, whether it's Postgres, MySQL, or so forth. How is data returned from the database? Does the web app process it in any way before sending it to the user? And then how is it included in the, say, HTTP response to the user? Is it in HTML or in an HTML attribute, JavaScript, and so forth? Like you have all these questions, right, when you're trying to reason about the security of a system. But what if I were to instead say, well, we've established the secure default or say invariant where our front end is React and we've banned dangerously set in HTML, which allows you to sort of opt out of the framework protections that prevent cross-site scripting. If we've done these things, then a lot of these other things are still relevant, but probably much less so than they were before. So we went from like having no idea about the security properties of our system to being like, well, I feel pretty good about this. Just by making this like strong guarantee and then enforcing it. So really, I look at this as 2 sides of the same coin, right? So on one side, we have finding bugs, which enables you to reason about sort of the security properties of your system and give you some sort of signals. And then the other is like, well, if we just say like, oh, there's this safe way that I know is like the security team has audited it, we trusted it. Like if we only do the safe way, then maybe this focus on finding bugs is not as important. You can also think about this as like task versus effort required. So for example, the units here are CHU or Clint's hand wavy units. So it doesn't take a lot of work to detect if something is either using or not using a secure library. This is pretty easy, but finding something that's potentially a bug takes even more work. Confirming something is a real bug takes even more work. And writing a proof of concept exploit that actually demonstrates that something is not just vulnerable, but exploitable in practice is even more work. So, why do these things that are very hard and take either a lot of analysis complexity or sort of manual human time, when ideally we can get the same security wins, same security benefit with just less work. And fundamentally, I guess the argument I'm trying to make here is that detecting the use or lack of use of secure defaults is just fundamentally much easier than finding bugs. Maybe we've got some tweens in the audience who we need to connect with, and for that I've included this meme. So broke is finding every vulnerability, and woke is preventing classes of vulnerabilities. Okay, so I think it's instructive to look at, okay, cool, like Clint, this is just your opinion, but what are these FANG company doing? Like the people and the companies who have big budgets, large security teams full of very smart, talented people. There's executive buy-in. The company believes security is important. There's a willingness to pursue long-term strategic initiatives, and who've generally thought of this a lot. So these are the people and the companies who I think it's very instructive to look at because they've been thinking about this for a long time. So let's look at a couple of examples. So this is a talk from Scott and Isha I really like from AppSec Cali. This is how the Netflix AppSec team is prioritizing their efforts, and they sort of had 3 core initiatives: secure by default, self-service, and security partnerships. And notice how secure by default is a big part and only growing over time. This is an interesting study from Microsoft, where basically they found that about 40% of the vulnerabilities they reduced between transitioning from XP to Vista, which is basically just like banning dangerous functions. So I think that's pretty impressive security wins for just like banning some functions. And there's like more details, but that's one of the key takeaways. There's a great book, Building Secure and Reliable Systems from Google, that you can download for free on this website that I've linked at the bottom. And they say that it's unreasonable to expect any developer to be an expert in security as well as building high performance robust systems, and be very vigilant when writing or reviewing code. A better approach is to handle security and reliability in frameworks, languages, and libraries. And ideally, the libraries only expose an interface that makes writing code that's vulnerable impossible. So I think that is very insightful. And maybe perhaps not easy, but we'll talk later in this talk about like how to do this rigorously and at scale. This is a great blog post from Facebook, who says, we invest heavily in building frameworks that help engineers prevent and remove entire classes of bugs when writing code. So there's sort of like a reverse or an inverse pyramid here on the right-hand side, where secure frameworks is sort of the base of it, but they also do automated testing tools, peer review, and so forth. So all of these things are useful and have value, but again, sort of the base, the most important part of this is secure defaults. And here's an anecdote so again, we've been looking at these like big established companies. This is actually from a hyper-growth Bay Area startup. They had like a couple hundred employees, but they were not massive at the time of this. So one of their security team told me, we were concerned about remote code execution in our Node.js apps. So we just banned eval, new function, and other things that could cause that to happen. They then wrote custom ESLint plugins that ran on every PR and just like blocked the pull request if it added one of these dangerous functions. And then they just didn't have to worry about these issues in their Node.js apps anymore. One thing my friend said that I thought was very funny is, you can get amazing security wins if you can be a bit draconian about coding standards. And obviously the caveat here is you need engineering buy-in. The security team needs to be supporting company goals and just doesn't naysay everything. So again, this is sort of within limits, but I think this is an illustrative example that this is very powerful and can be used by lots of companies, not just the biggest players. Okay, so hopefully I've convinced you a little bit about the power of secure defaults. So let's talk through a methodology for how you can target vulnerability classes. So this is actually an abbreviated version of a global AppSec SF talk my colleague Isaac and I gave. So if you want to see the extended, sort of longer, more detailed slides, feel free to check out that link at the bottom. Okay, so I just wanted to emphasize a little bit sort of the compounding effects of targeting bug classes rather than one-off bugs. So let's say you did a sort of time audit of your AppSec team, and you're like, okay, we spent some time, threat modeling, running security tools, cross-site scripting, and so forth. And let's say you thought, hey, cross-site scripting is really giving us a lot of trouble. Let's try to invest in, say, React or other secure defaults that allow us to basically kill this class of issue. So again, this is a lot of work, but if you were to do it successfully at scale, then all of that time you used to be spending on cross-site scripting, like finding, triaging, working with developers, education, all those things, you could then invest in another area, for example, say SQL injection. And by knocking out more and more of these pieces of the puzzle, you can gradually become higher leveraged and more systematically effective as an AppSec team, so you can support even bigger engineering orgs with the same or fewer people, is basically the idea. Okay, so the methodology is not crazy complex. It's just, first, evaluate which vulnerability class to focus on, then determine the best approach to either find or prevent it at scale. We're going to select a safe pattern, like what does good look like, and then make it the default everywhere. We'll train developers to use this safe pattern, and then we're going to use tools to enforce the safe pattern continuously and at scale. So let's delve into each one of these in a little bit more detail. Okay, so there's not really a best criteria for selecting which vulnerability class to focus on, but here's some common criteria that I see different companies use. So one is you might focus on, say, the most prevalent issues, the things that your organization has the most of. Maybe focus on the highest impact or risk. Maybe the easiest to tackle. For example, in your organization, some issues may just be like culturally easier than others, or maybe technically easier than others. Maybe your company has specific priorities that you want to listen to. But realistically, it's probably some weighted function of one or more of these. Okay, so first, in order to do this process, ideally you have like a strong vulnerability management program. So you want to know like what is your current state, like how are we doing right now? And then ideally, if your future efforts actually work, you don't want to spend 3 months working on some big initiative and then not have anything to show for yourself. So some of the things you want to track, for example, what's the severity of each vulnerability, which class is it cross-site scripting, SQL injection, or so forth? And ideally, like what's the source code responsible? Like what does the bad thing look like? And we'll look at that again in a second. So using this information, we want to build a list of sort of prior historical vulnerabilities our company has had. There's a bunch of sources for this you could look. For example, issue trackers like GitHub issues, Jira, and so forth. Maybe commit history. You could run a git log --grep and like XSS or SQL injection or so forth. Maybe you have static or dynamic analysis tools or fuzzing that's found bugs. Maybe a pen test reports, bug bounty, and so forth. So the goal, like regardless of how you find them, it's basically like let's build a list, a data set of vulnerabilities to review. And then we're going to review those for trends. So like let's look at all of our cross-site scripting. Let's look at all of our information disclosure and so forth. And within one bug class, we're going to try to figure out, does the vulnerable code look similar? Do these types of issues tend to manifest similarly in code? So in an ideal world, we want to choose a vulnerability class that is widespread across teams and repos. It's high risk, feasible to get developers to fix, aligns with company priorities, and ideally is always broken in the same way. So realistically, probably you're not going to find too many issues where all of these are true, but ideally some of them are true, because that just makes it more impactful if you were to tackle those issues. Okay, so number 2, how to find and fix at scale. So here I'm just going to call out that, depending on what you're trying to find, there's many approaches, right? So sometimes like maybe pen testing or bug bounty is the best approach. Sometimes maybe threat modeling or a WAF or some other tool is the best approach. But in this talk, just because of time constraints, we're going to focus on, if there is known good or known bad code, probably some like lightweight static analysis is a pretty good approach. But again, depending on what you're trying to do, there's many approaches that could be good. Okay, so 3, how do we select a safe pattern and make it the default? So perhaps your company has internal coding guidelines or standards, or maybe your own personal expertise. Personally, I'm a big fan of OWASP, so there's great projects like cheat sheets or ASVS that say like, hey, like do these things, don't do these things. So feel free to leverage the great things the community has already done. And then the second half of that, once you know what good looks like, how do we make that the default? So one way to do that is to update all internal coding guidelines, whether that's referenced by the security team or the engineering team. So this includes like READMEs, docs, wiki pages, facts, and so forth. And one thing that I think is very powerful is actually working with the developer productivity team, right? So can we make the secure version have an even better developer user experience than the old way? Like, can we increase developer productivity and security? Because if so, I mean, like, why would they not do that, right? Because they can move faster and do what they want to do anyway. So that would be a clear win for both parties. Another tip that I think is pretty neat is if you integrate security at the right points, for example, in new project starter templates. So let's say there's a repo developers fork to create a new microservice or a new application within your company. If you just put the security mechanisms into there, every time someone forks it, you'll get this automatic widespread adoption without having to sort of convince people to bolt on security later. And a quote from Asta I really like is hitch your security wagon to developer productivity. Okay, step 4, we want to train developers to use the safe pattern. So here are some tips for making communication successful, but obviously it depends on your company and your culture, and there's no sort of one size fits all here. So ideally, what and why something is insecure should be clear, using terms that developers understand without security jargon. We want to convey impact in terms developers care about. For example, risk to the business, damaging user trust, reliability, uptime, and things like that. We don't want to say like, oh, you should fix this because SQL injection and that's bad, right? Like what is the actual impact here? And ideally, how to fix should be concise and clear. So we want to link to additional docs and resources with more info, but sort of what we show them initially is just like, hey, here's exactly what's wrong, and here's what to do about it. Okay, so step 5, we want to use tools to enforce the safe pattern. So again, there's many things you could do, but for this specific case, we're going to use some lightweight static analysis to ensure that the safe patterns are used. Okay, so that was a high-level methodology. How you go about that in your company may vary depending on your sort of ecosystem, tech stack, and so forth. But here's some tools and techniques to take that idea and make it a little bit more concrete. So specifically, we're going to get a little bit into how do we set up continuous code scanning? What are best practices there? And then how do we check for escape hatches in secure frameworks? So there's been a lot of talks for various companies about how they do code scanning. This is probably not a complete list. In fact, I know it's not. But here's like Twitter, Salesforce, Netflix, Cisco, PayPal, Coinbase, Datadog, Dow Jones, and many more have all talked about how they do code scanning and just sort of continuous security testing in general. But here's some things that I think pretty much everyone agrees on, for at least the most part. Most companies, the unit of scan is pull request, because if you scan every commit, it can be a bit too noisy. For example, work in progress commits that may not make it into the main branch. Why annoy people? Ideally, scan should be fast, just a couple of minutes. Ideally, you don't want the security linting to be significantly longer than the rest of the build steps, because then you're slowing down development and angering developers. And this lets you give them feedback while context is fresh. Like who doesn't like that? If you want to do daily or weekly longer scans, you can do that as well. But I would really lean into sort of fast scans as much as you can. I see many companies adopting 2 different scanning workflows, which I think is interesting. So one is sort of an audit capability. This is more for the security team as consumers, and this is more like just visibility into what's happening. So for example, the development team may be like introducing new code that's say parsing XML or doing crypto, and it's not necessarily a bug, but like the security team might want to know about it, so that maybe they get like an asynchronous Slack alert when that occurs. Or maybe conversely, there's also like a blocking workflow where it's like, okay, these are like high quality, high signal checks that if they fire, we're pretty sure they're right. And we want developers to fix those, and maybe we break the build to encourage them to fix it. Another property is we want to make adjustment easy. So can we make it cheap to add or remove tools and add new rules, new checks? So there's a bunch of insights from Google's Tricorder paper that I think is quite excellent. So I encourage you to read it, that I've seen hold for a number of other companies as well. So ideally, the outputs of the tools you're using are shown within developer systems. For example, a pull request comment, rather than making them go to some separate tool. That's pretty bad developer user experience. The message you show users, ideally, again, is like clear and actionable, like what do you do, what's wrong, and link to more info if they're curious. The infrastructure should capture metrics, what checks are firing the most often. Again, this might feed back into your system of like targeting additional vulnerability classes for what's most prevalent or impactful. How long are the scans taking? What are false positive rates? One thing that Tricorder does, which I think is very interesting, is developers can provide feedback in terms of like, this is a false positive, or I don't care about this. And it actually automatically evicts checks that are too low signal, which I think is pretty cool. Because if you are annoying developers too much, this causes ill will with them, obviously. And it also can be too much operational time for the security team to sort of triage all these issues. Okay, so that was about like, how do we do continuous code scanning? So let's look at like, what scanning are we doing in the first place? And again, if we think about, if we as a company are leaning into secure by default frameworks, all we really need to do is detect the functions that let you opt out of these secure defaults. So for example, dangerously set inner HTML. We talked about this earlier, maybe exec, eval, or other shell exec type things. Maybe unparameterized SQL queries or like raw SQL statements. And maybe things that are specific to your company, like, make super user, or other things that you're like, anytime anyone calls this, like, I want to know, because that seems dangerous. So one way to do this is an open source tool my company is building called SemGrep, which is customizable, lightweight, and I think ideally suited for enforcing secure coding standards and best practices. So just like very little bit about it. It's open source on GitHub. You can check it out. It's LGPL, so use it however you want. It supports many languages, so Go, Java, Python, JavaScript, TypeScript, Ruby, and so forth. We're constantly adding more languages. Supports over 1,000 rules out of the box that are also open source on GitHub. It does not require buildable source code. So if you are running on partial source code, or maybe you don't have some internal dependencies and you can't resolve everything, like, it'll still work. But I think the most impactful thing is that there's no domain-specific language you need to learn. Basically, if you're trying to target Python code or Java code, it just looks like Python or Java. And why is it useful for AppSec engineers or developers? I think every code base in every company has things that are like, this is how we write software and this is how things work. So maybe that's on like a wiki or in the code itself or in your brain. But there's probably things that you wish you could enforce at scale. And I think SemGrep, or any lightweight static analysis tool, is a good approach for taking those ideas and ideally enforcing them continuously as sort of a GitHub action or a GitLab run or so forth. So I'll just give you like a quick example. So let's say we're like, well, exec is dangerous. Let's find all the times that happens in our code. Basically, this is one way to do that in SemGrep. And if you want, you can go to these slides and like click on these links, and it actually goes to, I'll do that for like 2 seconds. Basically, if you ever want to play with SemGrep without installing anything, you can go to the semgrep.dev and click on write. And basically, you can write a pattern here and see what's matched there. So let's say there's some like business logic in your company where you're like, well, hypothetically, we're a financial trading application. We want to call verify transaction before make transaction, because in our application, that's if you don't do that, it's a bug. So you can take that domain logic and business logic and sort of codify it into rules that run again on every commit. And so this is what that would look like in SemGrep. So again, it's basically like, it looks sort of like the code you're trying to find. The $sign return is like a meta variable, which sort of is like a capture group in regular expressions. But yeah, the point is like, you don't need to learn some totally separate, unrelated thing. You can usually get up and running in like 10 minutes or so. Okay, so maybe you're bought into secure defaults, but you're like, well, like that's going to be a ton of work. Like we have this huge existing code base. We would need to figure out like, what's the secure way? How would we flag when people are not doing that? So we're trying to make that as easy as possible. So we've created a couple of rule packs that are, of course, also free and open source. That are basically trying to detect like opting out of secure defaults. Like for example, here, this cross-site scripting pack, basically we went through the common web frameworks for Go, Ruby, Python, Java, JavaScript, and so forth, and said, what are all the ways to opt out of output encoding? Like, what are all the ways that you're basically disabling the security protections that your framework or library are giving you? And then we just flag those. So again, it's not necessarily saying this is exploitable, but if that rule packet doesn't flag anything, then you have reasonable confidence, assuming the rule pack is complete-ish, that you don't have cross-site scripting And similarly with insecure transport, we basically tried to enumerate for common languages, what are all the ways to communicate over HTTP instead of HTTPS? What are the ways to disable certificate verification? Basically, like, what are the bad, transport things that you could do? We just wrote lightweight fingerprints for all of those. So if you run that rule pack on your code, then probably you're communicating over HTTPS, or at least you're not doing anything obviously wrong. So we actually created some cheat sheets for these. So if you go to sort of the semgrep docs and go down a little bit, we basically created some cheat sheets to say, like, for Django, Flask, Java, and Rails, like, what are all the different ways that cross-site scripting can manifest? So I think this is useful for AppSec engineers as well as, say, security consultants, like people looking for bugs, because it's like, what are the bad things that I should be looking for? So, for example, server side, if you mark content safe, this does not escape HTML. Mark safe is one example of that, or like safe string. And basically we've enumerated, like, we spent a ton of time reading docs, reading various people's articles, and just trying to find, like, what are all the ways to, like, do something bad and dangerous. And we sort of enumerate each of these. And at the bottom, we have, like, this nice table, which is like, okay, like, if you were trying to enforce secure defaults, what would you do as an AppSec team? So you could say, okay, these are dangerous functions, ban them. This is what you should do instead. And then we also, where possible, have semgrep rules that you can just trivially run in your code to see if you're doing the right thing. So again, this is still early stages, but we're trying to basically make it as easy as possible for people to, like, one, know what the secure defaults are, two, measure how they're holding up against them, and just, like, roll it out at scale. So it's not perfect, but I think it's hopefully a step in the right direction. And again, you can get up and running and doing this on your code today for free using open source tools. Another thing that I'm pretty excited about is we're partnering with OWASP. This is still early stages as well, but the ASVS and cheat sheets project, we're trying to sort of, like, see how we can sort of combine forces. So for example, we want to automatically verify, is your code compliant with ASVS level 1, or find code that, say, violates cheat sheets best practice, either in, like, CI or in your editor. So yeah, Daniel Cuthbert, Joe Bolin, Rohit, and many others have been helping us out with this. So another thing, we don't want to be, another security tool that just, like, points out a bunch of issues. Ideally, we want to enable people to do the secure thing faster, easier, and ideally without AppSec team help, sort of self-service security. So there is initial support for autofix in semgrep. So here's an example. We have a GitHub action that you could say, hey, this rule matches all unauthenticated routes, and you could write a comment like, hey, it looks like you're not doing a JWT auth check. Please add this code, and then you can just, like, click a button to add it in. So if you want to look at, like, what this rule is that actually created this, you can click here, and if you want to, like, see what it looks like, you can go there. So you can imagine, like, oh, this is how my company does accesses secrets. This is how my company, like, we used to use this one API, now we use this new API. All of these things you could codify and, where possible, add, like, an autofix. So say new developers could get up to speed faster, or, et cetera. But again, the principle here is the same. The tool doesn't really matter. And yeah, we have a VS Code extension as well, if you want some coverage in your IDE and not wait until just CI time to give developers feedback. And this has actually caught a number of bugs that I've written as well. This one I think is pretty tricky. So with requests library, if you don't pass a timeout, it defaults to, like, never timing out. So your code will just hang if the server doesn't respond. So I've done that many a time, and it caught it for me, which was nice. Okay, so let us wrap up. Just quickly, I think this was mentioned at the beginning, but if you're curious about keeping up with the latest and greatest in security, I have a free weekly-ish newsletter at TLDRsec where I try to talk about the latest, like, tools and resources and some work that I'm doing. There's a handful of people who like it, so maybe you will. And actually, one thing that just launched today, actually, which I'm super excited about, is I was collaborating with my friend Mark Manning, who wrote a excellent, super detailed guide on analyzing Kubernetes clusters. Yeah, so super detailed. I would encourage you to check it out if you care about Kubernetes security. All right, so in conclusion, I think secure defaults are the best way to scalably raise your security bar. Killing bug classes rather than one-off bug finding makes your AppSec team more leveraged. The overall process is to define a safe pattern, educate developers, roll it out everywhere, and then enforce it continuously. And ideally, to do that, you have a tool that's fast and lightweight. SemGrep is one example, but you could use any tool. And again, focusing on developer user experience is very important. So if you like these slides, feel free to go to that link. Also happy to chat on Twitter or LinkedIn. And yeah, thanks so much for your time. I'd love to chat about it and ask or answer any questions.
Awesome, Clint. Yeah, we were. I'm seeing if there's any questions that popped up during it. I especially like. I've been playing more and more since we had our. And I realize my lights on are. I'll turn them on here shortly. But I've been playing with the in-browser SemGrep tool. Just as I've been, implementing different rules and analyzing code bases, it's pretty powerful, right? Like I feel like it fills that niche. I know you talked about this already, but kind of that niche between full-blown static analysis and, hey, we need a good way to quickly assess whether or not we're doing the right things.
Yeah, it can be used for bug finding as well, and we have used it for that. But I think it does excellently fit the niche of like I know that this is bad. Show me all the places this happens.
Yeah.
You've probably done a bunch of consulting projects as well, where you're like either dynamic testing or code auditing. You're like, oh, this thing is bad. Show me all the places this happens. And for me, that was like super painful before. Usually involved like running rip grep a bunch of times and triaging like a million things.
Yeah. Yep. IDE searches and then spinning through thousands and thousands of lines of code to find the 10 where it was actually being used, right? So, well, good. Like, how have you seen the uptick there, right? Like, I know you haven't been at R2C long, but what has the response been from SemGrep? I know you've been pushing it quite a bit, but how do you feel like the community is responding?
Overall, pretty well. Like, I think more positively than I expected. Like a lot of times, people just sort of proactively reach out and they're like, "Oh, hey, like this is super cool, thanks." Or like people write blog posts about it. Like Marco Lancini wrote an excellent post recently about running it on infrastructure as code. And I had no idea he was working on that until I saw it, until someone sent me a link on Twitter about it. I think we see like a lot of people who aren't us writing SemGrep rules. And I think what I find the most exciting and promising is developers proactively taking on SemGrep for like enforcing like secure code, not really secure coding, but more just like best practices and like anti-patterns and like, man, I always have to comment on this in like my pull request. So like, I'm just going to write a pattern that makes sure that people do that. So yeah, because I mean, the dream is like, oh, the developers have already brought in this tool, and then the security team is like, cool, let's use that tool also for security, because then you don't have to fight anyone and get them to use it. So I'd say still, lots of room to grow, but so far it's been nice.
It's been good, and I'm also like I didn't realize that you were starting to work with OWASP for the ASVS standard. That feels very powerful to me, right? Like from a cheat sheet perspective, rolling that in, right? Yeah, that's super exciting. That's all I wanted to say on that. Kudos for reaching out. I mean, is there any sort of timeline on when that's expected to be completed, or is it, do we need to go bug Brian Glass or somebody to go finish the OWASP side of things for us?
Professor Glass.
Professor Glass. Sorry. Glass.
Yeah, we've been, I would say early stages, but I think we'll probably see more of that in like Q1, Q2 next year. Yeah, we've been honestly, like it's something that's been on our mind for a while, but we've been sort of taking it slow because, we're like huge fans of OWASP. I've been attending conferences for many years and I don't want to be like, oh, here's this thing, let me like shove it in. So we've tried to be very like careful and respectful to be like, hey, like, what do you all want? Here's what we're thinking about. And just trying to do something that like everyone wins from without trying to like, do something that people aren't excited about. But yeah, everyone we've chatted with has been like pretty stoked about it. And have been interested in contributing as well. So actually, one thing we're thinking about doing is having like a mini hackathon where we're like, hey, let's try to get coverage of like this parts of ASVS or cheat sheets, and then like collectively as a community, we all sort of like contribute over like a week or two. So yeah, we're tentatively hoping to do that early next year. So yeah, I'll let you know.
Yeah, do. I mean, we'd love to promote it on the podcast or on, here, right? Anywhere that we're associated with. We're super excited about the project in general. So,
yeah, thank you.
Good. Well, let's see.
And I had played with SimGrep too, and I loved it. So, thumbs up.
Nice.
Like recently, within the last 2 weeks. So
yeah. Yep. Well, good. I think we'll give people then a couple minute break. I didn't check on Slack to see if there was any other additional questions.
No, there's no additional questions on Slack.
Good. All right. Well, we'll give people a 5-minute break. We've got Adam that's joining us here shortly, but we will we'll pause for a minute. Clint, again, thank you as always for coming on, contributing and giving us of your great knowledge. And again, I can't promote TLDRSec enough. Right? Like it's a great little snippet of code and security goodness that comes into my inbox. And so go sign up if you haven't done that yet.
Yeah, thanks so much. Always a pleasure hanging out with you all. And happy holidays and hope to see you soon.
Yep, great. All right. Thanks, Clint.
Thanks.
Thank you. Cool.